Assalamu alaikum. What are the factors that affect on resistance of a wire? Yeah. If we have a rod or wire, had a length, so it has a resistance. What will happen if the length increases? The resistance increases. So the resistance depends on the length of the wire or the rod. So it is direct relation. So the resistance denoted by R. So the resistance denoted by R proportional directly to the length of the wire. What about the cross-section area? When the cross-section area increases, the resistance decreases. So it is inverse proportion. So the resistance proportional inversely to the cross-section area of the wire. Now we can collect the two relations. We can say that the resistance directly proportional to the length and inversely to the cross-section area. So the resistance here proportional directly to the length and inversely to the cross-section area. In mathematics, we can convert the proportional relation to equation and we write constant. So from this, we can say R equals constant multiply L over A. This constant depends on the material called resistivity. So R equals constant, this constant called resistivity denoted by rho. So R equals rho L over A, rho. So the factors that affect on the resistance of a wire is length of the wire, cross-section area of the wire, also temperature of the wire. The fourth one, material. So that are four factors affect the resistance of the wire. Now, what is the relation between R and rho? Who is rho? It is a resistivity of a wire. Now, when we rearrange this formula to get rho equals RA over L. If the conductor has cross-section area 1 meter squared and length 1 meter, so in that case rho equals R. So the resistivity is the resistance of a conductor if its length is 1 meter and its cross-section area is 1 meter squared. What about the unit of resistivity? Unit of resistivity, we can get it from this equation. Unit of resistance is ohm. Unit of area is meter squared. Unit of length is meter. We cancel 1 meter with 1 meter squared, so it's ohm meter. So the unit of resistivity is ohm meter. Take care, it is not ohm per meter, it's ohm meter. Now, the resistance depends on the shape of the wire, length and area. But resistivity depends on the material. Different material, okay? So this material not the same like this. Each material has own resistance. So the resistivity depends on the material, but the resistance depends on the shape of the wire. So here the resistance depends on the size and the shape of material, but the measure of how much a particular material opposes electron flow is called resistivity. So now we need to compare between resistance and resistivity. Okay, now resistance and resistivity. Resistance denoted by what? Denoted by R. Resistivity denoted by what? Rho. Resistance depends on the length of the wire, the cross-section area, the shape and size. But resistivity depends on material. What is the unit of resistance? Ohm. What is the unit of resistivity? Ohm meter. When the resistance equals the resistivity, R equals rho, when the length of conductor is 1 meter and the cross-section area is 1 meter squared. Now, we need to solve the question. Now, let us see that question. We read the question. A nichrome wire had a length 1.5 meter. So L equals, equals 1.5 meter. And the cross-section area, so this is the area, equals 0.008 millimeter squared. We need to convert from millimeter squared to meter squared because the area must be in meter squared. We have a good relation between the units of area. So remember, units of area, that meter squared, and then decimeter squared, centimeter squared, finally millimeter squared. When we go down one step, multiply by 100. When we go up one step, divided by 100. Now, 1 millimeter squared to go up meter squared. So we go up 3 stairs, divided by 100, divided by 100, divided by 100. It means divided by million. It means multiply by 10 to the power negative 6. So from millimeter squared to meter squared, multiply by 10 power negative 6. Now, the area here, we convert it to meter squared. So it is 0.008 multiply 10 power negative 6 to be in meter squared. Resistivity is 1.3 times 10 power negative 8 ohm meter. So also we have here the resistivity. Rho equals 1.3 times 10 power negative 8 ohm meter. Calculate the resistance. So we need R. What is the formula of resistance? Remember, R equals rho L over A. Now we do substitution. Rho, it is the resistivity, which is 1.3 times 10 power negative 8. L is the length in meter, 1.5. A is the area in meter squared, 0.008 multiply 10 power negative 6. We can calculate R. From this, by using the calculator, so fraction 1.3 multiply 10 to the power negative 8 multiply 1.5 divided by 0.08 multiply 10 to the power negative 6. The answer is 2.4. Okay, so the resistance is approximately to 1 decimal place, 2.4 ohm. Unit of resistance is ohm. Calculate the length of the wire. Now that was part A. Part B, we said calculate the length, we need L, of a wire which would be needed to make an element of electric heater of resistance, or the same material, so the same resistivity, but now the resistance is not the same. So in the second part B, we have R equals 30, and resistance and resistivity is given. It's okay, but we need L. So in the second part, we need L. Rearrange the formula. R equals rho L over A. We can do cross multiply. So RA equals rho L. From this, L equals RA over rho. R is the resistance. It's given 30 ohm in part B, 30. The cross-section area, it is the same, 0.008 multiply 10 power negative 6 divided by resistivity. Also the resistivity is the same, which is 1.3 times 10 to the power negative 8. 1.3 times the 10 power negative 8. Now we use the calculator to get the length. Fraction 30 multiplied by 0.008 multiply 10 to the power negative 6 divided by 1.3 times 10 to the power negative 8. The answer is 18.46, approximately 18.5 meter. I hope you understand this lesson. Thank you.